Welcome. In this video I'm going to show you how you can perform a post-hoc residual analysis after a goodness-of-fit test using binary test or a residual test and Excel and my stikpetE add-in. Now my add-in is available on my GitHub account. You can see the link over here. Once you've downloaded the file, you should open Excel, then go for File, Options, Add-ins and click on Go. Then browse for the add-in and that should install it and should give you access to additional functions within Excel. To show you how this actually works, I have some example data in column A, and the function of interest is pH, short for post-hoc, residual, goodness-of-fit test, and then binary. Now it actually only needs data as its input, but that should be a vertical range specified, so not an entire column A, but really from here to all the way down. If you like, you can specify which test you want to use, either adjusted residuals, standardized residuals, binomial, Wald, or score test. The expected counts, if you have them, otherwise it will just assume every category to be equal. You can set which multiple testing correction to use, either Bonferroni, CDAC, Hommel, Home, CDAC, Hofburg, BH, BY, or Hommel's original one. A two-sided method to be used if you have a binomial test, and the continuity correction if you're using a score or Wald test. Now this will actually compare the observed counts with the expected counts of each category. If you want to compare each possible combination, so if two categories might be different from each other, then you could use a pairwise analysis. I have separate videos on those. You could also, instead of using binary tests, you could use a chi-square test or a goodness-of-fit test. I have a separate video again on those as well. Now, it's fairly straightforward. I simply enter the function name and I specify the range, and that's all that I need. It's an array function, so it will actually not just put the output in one cell, but actually over multiple cells. It shows the category names, of course, the observed counts in each, the expected count, and because I didn't specify, it's equal for each of them. It's done, as you can see in the last column, an adjusted residuals z-test. On my website you can find the formulas if you like. That z statistic, the p-value and the adjusted p-value. Usually this is the column of interest. If that's below 0.05, then most likely that's the usual threshold. That's the case for almost all of them except for never married. So never married was not significantly different from its expected count, while all the other ones seem to be. Now if you do have expected counts, as mentioned earlier, you can just list that as a small 2 by x table. So 2 columns and then a number of rows is the number of categories. And you can add that into the function. You can also specify which adjustment to use. So in this case I'm using CDAC and I get slightly different results, especially now because of these expected counts. And as it turns out now, married isn't significant, is significant, but divorce isn't. Separate is still significant. Never married is also still significant, and widowed is no longer significant. Here's an example where I'm using a Wald test instead of a residuals test, and here's a version where I'm using a binomial test. Alright, I hope this video was helpful and thank you for watching.